Hello and welcome. This is a presentation on selecting and designing instruments brought to you by the Student Affairs Assessment Support Service for the Center for Assessment and Research Studies at James Madison University. Selecting and designing instruments is the third step of the learning assessment cycle, and it is completed after establishing objectives and mapping your program to your objectives. In order to properly map instruments, student learning objectives must be established and very clearly articulated. This ensures that you select the most appropriate measures to assess student learning outcomes. There are two ways to map instruments to objectives. First, you may use pre-existing instruments that assess your construct of interest. This process is much easier than writing your own items, and pre-existing instruments tend to have existing validity evidence, so it's much less time-consuming. Another way to map instruments is to develop your own measure. This is very time-consuming, and it can take months or even years to complete. However, there are benefits to tailoring items to your specific objectives. If you do choose this process, be aware that instrument development is an iterative process that requires much revision. There are several things to consider when selecting and designing instruments. First, the number of instruments depends on your objectives. You might have one instrument per objective, or you may have one instrument that assesses all of your objectives. The number depends on the characteristics of your objectives, such as how many you have, the knowledge and skills they cover, and how detailed they are. The type of measurement is also important to consider. Direct instruments require students to demonstrate knowledge and skills. For example, to assess how well students understand calculus, one would administer a series of calculus problems and ask students to solve them. Indirect measurement involves collecting information about students' opinions or beliefs about their knowledge and skills. For example, an indirect measure of calculus skills would ask students something like, on a scale of 1 to 10, how well do you know calculus? Length of the instruments is also important. Longer tests might cover more content, but could potentially cause fatigue that affects test scores. However, short tests might not cover every objective you want to assess, so it's essential to find a balance. Ideally, one would choose an assessment that covers the objectives but isn't cumbersome for students to complete. We use psychometric evidence to evaluate instruments, and this can become quite complicated. But generally speaking, we need to consider reliability and validity. Reliability refers to the consistency of scores, or the absence of inconsistency. Inconsistency in scores or error may exist across items, test forms, or time. Validity generally refers to the extent to which evidence and theory support the adequacy and appropriateness of score-based interpretations and uses of test scores. Simply put, evidence is needed to justify your interpretation of test scores and any decision that results from using a test, such as placing a student into a special program. You should always carefully consider reliability and validity evidence in this phase of the assessment cycle. When selecting instruments, one question you may have is, where do I find them? In order to find existing instruments, you must research the construct of interest. Search articles from your field's journals. You will often find descriptions of measures, validity studies, and even instrument reviews that will be helpful in your instrument selection process. A test database is another option. Many fields have their own test databases with a variety of instruments. When designing instruments, it's important to understand the potential length of the process prior to taking it on. Instrument development requires an extensive literature review on your construct of interest, mapping items to each aspect of the construct, training item writers, and revising items based on psychometric information, such as item difficulty and discrimination parameters. In addition, psychometric evidence does not exist for new instruments, so you may need to conduct multiple validity studies to justify your intended interpretation of test scores. You should only design your own instrument if there are no other existing measures that can assess the construct in which you're interested. If you choose this route, SAS can provide literature to assist you in this process. The take-home message is to follow the learning assessment cycle and ensure you have well-articulated student learning outcomes to which you can map your instruments. Selecting instruments is always the preferred course of action over designing your own. Consider the type of instrument you want to use, how long they are, and how many instruments you will need. Psychometric evidence is essential when evaluating an instrument. See the Standards for Educational and Psychological Testing, a publication by the American Psychological Association, for more information about reliability and validity. Finally, if you choose to design your own instrument, prepare yourself for the long process ahead. This concludes the presentation on selecting and designing instruments. Thank you for your time and attention.